YouTube channel. Today we'll be discussing probability, but we'll focus our attention on probability that has to do with replacement and without replacement. If you are just watching this video, on this YouTube channel we have been able to iron out probability on addition, on multiplication, and probability on occurrence not happening. You can check that out. But as we journey through this video, we only focus our attention on probability with replacement and without replacement. We have a question on the screen. Let's see how we can deal with this question. A basket of 40 oranges contains 5 which are bad. An orange is drawn at random from the basket and then a second orange. Determine the probability that neither of the oranges is bad when drawn with replacement, without replacement. 2. Determine the probability that neither of the oranges is good when drawn with replacement, and secondly without replacement. So let's see how we can solve this question. Let's see solution number 1. Now, first thing first, let's bring out our parameters. We have 40 oranges. So we see total oranges. How many? 40. We are told that contains 5 bad oranges. So let's see bad oranges. How many? We have 5. So by implication, if we have total oranges to be 40, 5 are bad, it means those that will be good will definitely be 40 minus 5, which will give us what? 35. Awesome. Now, let's say for solution number 1 now. For 1i, with replacement. Now the probability that, because the question says we should determine the probability that neither of the oranges is bad. Two drawn were made at random, the first one and the second one. So the question is asking us, we should determine the probability that neither of the oranges is bad. That means the 2 oranges that were drawn one after the other, that means they are good. That's what the question is saying, that neither of the oranges is bad when drawn with replacement or without replacement. That means the 2 oranges drawn, they were good ones, because they said neither of the oranges is bad. That is what the question says. So the probability that the orange selected on first drawn now, orange and the first drawn, the probability that the orange selected on the first drawn is good will be total number of good orange over total number of oranges, because we're told that neither of the oranges is bad. So what we just do is, let's get a template. So we just say good oranges over total oranges. Because that's what the question is asking from us. Neither of the question says we should determine the probability that neither of the oranges is bad. Now, the first drawn, when the first orange was removed, so those good oranges, we have how many of them? 35. And bad oranges, okay, total is how many? 40. Okay, and good oranges, we have how many of them? We have 35. Awesome. So when the first orange was removed, this is what we have. So by implication, 35 over 40, these ones can cut themselves. So 5 can go in 35, 5 can go in 40. So if you remove, you say 5 in 35, it's going to give us 7. Then 5 in 40, it will give us what? 8. Now, that's the first drawn. But we are dealing with replacement. That's the first drawn. So with this, we can now say, let's make use of this. That's the first drawn. But what? The orange is replaced. Now, when the first drawn was made, this is the probability that the orange selected on the first drawn is good. After drawing it from the pool of the oranges, then the orange is replaced. Then let's make a second drawn, because we were told from the question that an orange is drawn at random from the basket and then the second orange was drawn. So when the first one was drawn, it was replaced. That means all the number of oranges will be complete then. So the second drawn was made. Second drawn was made. So the probability that the orange selected on the second drawn now, because after the first drawn was made, we got the probability, but we will replace it. So the probability for the second drawn now, the probability that the orange selected on the second drawn now, so the probability that the orange selected on the second drawn is good. So we have good orange over total oranges. Because it was actually replaced, that means all the number of the oranges will still be complete. So we still have the the same issue that we have here. Beautiful. Good oranges, they are 35. Total oranges 40. So if you say 5 will go in 35, will give us 7. 5 will go in 40, it will give us 8. Beautiful. Now, the probability that both the first and the second orange is good, or if you are to use the English use here, the probability that neither of the oranges is bad. If you say neither, the probability that neither of the oranges is bad is still the same thing that the two oranges are good, because they say neither is bad. Because we are dealing with 2 here. So therefore, let me use this. Awesome. Therefore, the probability that both the first and the second oranges and the second oranges is good will be, don't forget, in our multiplication law of probability, we're able to establish that the moment the word and is being used, that means you are going to be multiplying. You are going to be doing what? Multiplying. So the first and the second oranges, they were good. So don't forget this, when the first one was drawn, it was replaced before the second one was drawn. So this is the first one and this is the second one. The two were drawn. So if we say let's multiply our answer. 7 times 7 will give us 49, and 8 times 8 will give us what? 64. Awesome. So the probability that both the first and the second oranges is good is 49 over 64, because they cannot cut. So if you are to go by what we have here with replacement, when the first orange was drawn and it was replaced, the probability that both were good, that is, neither of the oranges is bad, is what? 49 over 64. Awesome. So let's deal with, because this one is with replacement. Now without replacement, when the first one will be drawn, it will not be replaced before the second one will be drawn. So now this is without replacement. That one, when the first one was drawn, it was replaced. This one, when the first one will be drawn, it will not be replaced. Let's try and see what we have here. So let's just make this as a template. Beautiful. Now the probability that the orange selected on the first drawn is good will be good oranges over total oranges that we have here. Good oranges, they are 35. total oranges, they are 40. By implication, it means if we say 5 will go here, we'll have 7. 5 will go here, we'll have what? We'll have 8. The probability that the orange, now without replacement, it means if you are not replacing it, since the orange is not going to be replaced, the total will now be, instead of the total to be 40, the total will now be 39. The good oranges will now be 34. That's the meaning, without replacement. Unlike this one, then the orange is replaced. But this time around, then the orange is not replaced, because we are dealing with without replacement. Then the orange is not replaced. Awesome. So since the orange will not be replaced, the orange is not replaced, total oranges will now be, total is 40 before. Now an orange has been drawn, is not replaced, total will now be 39. Then the good oranges will now be what? The good oranges before, they are 35. Now they will now be 34. Awesome. The probability that the second is drawn. Okay. Now, the probability that the orange selected on the first drawn is good. On the second drawn now, the probability that the orange selected on the second drawn now, because it is not replaced this time around, because it is not replaced now. So let's make use of this template. Now it is not replaced. Now that the oranges is not replaced, the good oranges will now be 34. Now be 34. And the total oranges will now be what? 39, since it is not replaced. Therefore, let's make use of this template. The probability that both the first and the second oranges is good now. Therefore, the probability that both the first and the second oranges, those ones that were drawn, is good now, will now be, now that this one is good, that's the first one, but the second one now is drawn without replacement. This one is drawn without replacement. Awesome. So if you are now multiplying, if you are multiplying 7 times 34, give us, we can cut so that will not be, or we can multiply any one that suits you. You say 7 times 34 to give you 238. 238. And if you say 8 times 39, it will give you 312. Awesome. Now, we can, for us not to be working with big numbers, we can still cut both the numerator and the denominator with 2. 2 can cut this and this. So let's see what we have here. Two can cut 238, we'll be left with 119, and 2 can cut 312, we'll be left with 156. So we have 156, and we have 119. Awesome. So now that the oranges are drawn without replacement, this is the probability. Good. So for question number 2, what we are going to do now is to make use of this template, but a little different now, because this time around we have to determine the probability that neither of the oranges is good. That means the reverse of this now. This one, they say neither of the oranges is bad. That means we'll be dealing with good orange. That is, those oranges are not bad. This one, they say we should determine the probability that neither of the oranges is good. That means the 2 oranges drawn, neither is good. That means they are bad. So we'll be working with bad oranges this time around. Okay. Let's get this as templates. Then we'll be editing as we journey through. Okay. Let's quickly do that. Use it as a template. But as we are doing that, we need to be very careful. Awesome. Let's start from here with replacement. Now, the probability that the orange selected on the first drawn is bad now. With replacement, the probability that the orange selected on the first drawn is bad will be bad oranges over total oranges. You need to be very careful. Hope we are using the right one. I think yes. So bad oranges now, we have 5 of them over total oranges, which is 40. Good. So 5 can cut here 1, 5 can cut here 8. So we'll be left with what? 1/8. Beautiful. Now, then the orange is replaced. Then a second drawn was made. A second drawn was made. Let me check what we have here. Then the second drawn was made. Very good. You can continue now. Then the second drawn was made. the probability that the orange selected on the second drawn is bad now, because we replace it with bad oranges over total oranges. So bad oranges, we have how many of them? We have 5. Total oranges, we have 40. So if 5 can go here 1, 5 can go here 8. So we now have this to be what? 1 over 8. Beautiful. Therefore, the probability that both the first and the second oranges is bad will now be, because they say neither of the oranges is good, so that means they are bad. The first one is 1 over 8, and the second one is what? 1 over 8. Beautiful. So 1 times 1 will give us 1. And 8 times 8 will give us 64. That's sorted out for the first one because it is replaced. Beautiful. Now, without replacement, the probability that the orange selected on the first drawn is bad. This time around, the first one is drawn. The probability that it is bad will now be bad oranges over total oranges. We have 5 oranges that are bad. All the total oranges, they are 40. By implication, it means if you say 5 will go here 1, 5 will go here 8, we are left with what? 1 over 8. Beautiful. Then the orange is not replaced this time around. The orange is not replaced. Since the orange is not replaced, total oranges will now be what? Will be 39. But bad oranges will reduce also. Since the orange is not replaced, total oranges will now be 39. Since the first orange has been drawn, then the second one will be drawn now, but it is not replaced. So bad oranges will now be, instead of 5, you know there are 5, they will now be what? They will be 4, since the first one is not replaced. Now, the probability that the second orange selected on the second drawn is bad now will now be bad oranges over total oranges. So bad oranges, they are how many? They are 4. Total oranges, they are how many? They are 39. Awesome. So we've been able to iron out that. Therefore, the probability that both the first and the second oranges is bad will now be (1 over 8) that we have here. That's the first one drawn, over times 4 over 39. 1 over 8 times 4 over 39. Awesome. So you see 1 times 4 will give us 4. 1 times 4 here will give us what? 4. 8 times 39 will give us 312. Awesome. So I think this can cut. We can start with 2, or we can use this 4 straight. 4 will cut. We can use it straight. Okay, let's use it straight. So if you say 4 here 1, 4 in 312 will give us 78. 4 here 1, 4 in 312 will give us what? 78. Awesome. So we're able to iron it out. You can Pause, rewind this video for clarification and understanding. Kindly drop a comment with us if you have any issue with any of our videos. Help us like this video and subscribe to this YouTube channel. Don't forget to press the notification bell whenever we post a video so that you can receive an update. Thank you.